In this video, we're going to look at the fundamentals of logarithms. This video in particular is going to cover some of the basic concepts with a few basic examples for each scenario. In the next video, we'll look at how all these concepts can link together to help solve logarithmic equations. For those who don't know me, my name is Chris Iannazzoni. I've been tutoring for about 2 years now, and I make these videos so that VC students can do the best they can in math methods. With that out of the way, let's get into it. The logarithm can be thought of as a rearranged version of the exponential. Say, for example, we have the exponential y equals a to the power of y. As a logarithm, that will just be rewritten as x equals log ay. All we've done there is just shuffle the terms around. The reason we do this is because it brings the power from an exponential equation to become the subject of a new equation. So if you want to solve for x, then converting to a logarithm is by far one of the most reliable ways of doing that. For example, if we have 4 equals 6 to the power of x, and we want to solve for x, then all we have to do here is convert to a logarithm form by just swapping the order of all those terms. It's more accurate to say that the logarithm and the exponential have an inverse relationship. If you recall from your earlier studies when it comes to inverse functions, you can find the inverse of any function by swapping the x and the y and then solving for y. When you do that for exponentials, you get a logarithm. All logarithms have a base. Some bases are much more common than others. The most common one is the natural logarithm, which has a base of e, which can be expressed either as log e of x or ln of x, which is pronounced natural log of x. The other logarithm that shows up is the so-called common logarithm, which has a base of 10. So you can express that either as log 10 of x, or you can use capital L log of x. Just like how there are index laws for exponentials, there are also logarithm laws for logarithms. Before we dive into the specifics, it's worth covering a few key rules. The first major one is that the logarithm laws only apply if the bases of the logarithm are identical. And the second major thing to consider is that the logarithm laws will only ever work if the coefficients out the front are identical. To make life easier, we say that the coefficients should be equal to 1. Now, this isn't strictly true, but it does make life a little bit easier if you rearrange your equation to take any coefficients off of your logarithm before using the logarithm laws. If you already know how to handle the coefficients, then by all means keep doing that. This is just to keep things simple. If the brackets of a logarithm are a product of two terms, then that logarithm can be expressed as an addition of two new logarithms that have the same base. This also works both ways. If you have two logarithms with the same base that are added together, then you can combine those down into a single logarithm with the same base that has the product of both of those terms in the brackets. In fact, it's worth mentioning that every law that we look at will work both ways. For example, if I had log 2 of 4 plus log 2 of 5, then I can combine those down into a single logarithm, which becomes log 2 of 20, the product of 4 and 5 being 20. If the brackets of a logarithm are a division of two terms, then you can express that same logarithm as two separate logarithms that are subtracted from each other. For example, if I have log 2 of 4 minus log 2 of 5, then that can be condensed down into a single logarithm, that is log 2 of 4 divided by 5. Just remember that it's the second logarithm that becomes the denominator. If the brackets of your logarithm are raised to a power, then that power can be brought out the front of the logarithm. For example, if I have log a of x to the power of 4, then I can rewrite that as 4 times log a of x. It's worth noting that the entire bracket needs to be raised to the power for this to work. For example, if I had log a of 2 times x squared, then I can't take the power of 2 at the front because the 2 was not also squared. But this would work if I had 4 times x squared, because I can rewrite that to then have a power over the entire bracket and then take that out instead. These are kind of like the log laws, but they're more so just quirks that are related to the original exponential version of the equation. Let's take a look. If the base and bracket of your logarithm are identical, then that logarithm will always equal 1. Let's pretend for a second that I didn't just tell you that it equals 1, and we don't know what it equals. Let's call our result y as some unknown. If we were to convert our logarithm to an equivalent exponential form, we would have a to the power of y equals a. If you recall from your earlier studies in exponentials, using equating coefficients, you can see very quickly that the only valid solution for y is going to be 1. It's for this reason that any time the base and bracket of your logarithm are identical, the result will always be 1. If the bracket of your logarithm is equal to 1, then that logarithm will always equal 0. And again, we prove this by converting to exponential form. When we do that, we get a to the power of y equals 1, which will only ever be true if y is equal to 0. If your brackets are negative, then there is no real solution to that logarithm. Now, I specify no real solution because technically there is a solution to this, but that's a special math thing, so we don't have to worry about that here. If we convert to the exponential form, we see there's an impossibility here. There is no valid power of y that will convert a positive base to a negative number. Now, also in math methods, you never have to worry about having a negative base, so that also doesn't apply here. If the bracket is 0, then the logarithm will always be undefined. Once again, proving this by converting to the exponential form gives us the equation a to the power of y equals 0, which once again, there is no power of y that will get our exponential to exactly equal 0. We can get close with a very large negative number, but close to 0 is a far cry from being exactly 0. If your exponential is raised to the power of a logarithm that has the same base as your exponential, then that entire term can be simplified down to just whatever's inside the brackets of that logarithm. Why? Well, once again, let's convert to exponential. That's going to give us a to the power of y equals x. Now remember, y originally was log a of x. So all we're going to do is replace the y that is in the power with that original logarithm. And sure enough, we've proven our identity. The last thing we'll look at is how to convert the base of your logarithm. And we do that using the following procedure. We start, as always, by converting our logarithm to an equivalent exponential form. From here, we apply a logarithm that has the base that we want to both sides of that equation. This just means that you take both sides of the equation and you wrap a logarithm around both of them. From here, we just rearrange for y since that's what we started with. And we can start to achieve that by using the power law, taking that power of y out the front of our logarithm and then finishing up by dividing both sides by that left-hand side logarithm. If you compare where we started to where we ended, you'll notice that we started with a logarithm that had a base at a, and we converted it to two logarithms that have a new base of b, which was whatever we wanted it to be. Strictly speaking, if you just memorize the formula, that works too. My personal preference is to use the three-step process here because it uses stuff that you already know from previous logarithm law stuff, rather than having to memorize an additional technique. But yeah, if all you want to do is memorize the final formula, then that works fine as well. In the next video, we'll look at how all these techniques can be used together to help solve logarithmic equations. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.